In your lesson today, you're going to have more practice working with complex fractions. And in our first question, we're told that Allison and her classmates planted bean seeds at the same time as Yuki and her classmates in Tokyo did. Allison is video chatting with Yuki about their class seedlings, and we want to know who should expect to have a taller plant at the end of the school year. And looking at the picture in front of us, we can see for Allison's plant that it grows 2.5 inches in 5 days, and for Yuki's plant, it grows 5 5/10 centimeters in 4 days. And since these are a different number of days, we're going to have to first figure out what their unit rate is per day. So we're going to start with Allison. And for Allison, I'm going to be interested in how many inches per day her plant is going to grow. So I know that it grows 2.5 inches in 5 days, and I'm going to set that equal to another ratio where my denominator is 1 because I want to know how much it grows in 1 day. So I'm going to have to scale back by dividing by 5 here. 5 divided by 5 is 1. And if I do 2.5 divided by 5, well, that's going to be 5/10. And so for Allison, I know that her plant grows 1/2 inch per day. I'm going to do something similar for Yuki. Okay, for Yuki, she's measuring in centimeters and days, and her plant can grow 5.5 centimeters in 4 days. And again, I want to know how much it's going to grow in 1 day, so I'll set that equal to another ratio with the denominator of 1. And we'll have to scale back by 4 this time. 4 divided by 4 is 1. And now I'll do 5.5 divided by 4, and that's going to give me 1 375,000. And so Yuki's plant grows 1 375,000 centimeters per day. Okay, so I have their unit rates, but I still can't make a comparison yet because they're measuring in different units. For Allison, she's measuring in inches per day. Yuki's measuring in centimeters per day. I need to know what the relationship is between inches and centimeters. And fortunately, I know that 1 inch is equal to 2 54 centimeters. 1 inch is 2 54 centimeters. How's this going to help us? Well, I know Allison's plant grows 1/2 inch per day. So if 1 inch equals 2 54 centimeters, I'm going to figure out how many centimeters 1/2 inch is going to equal. 1 divided by 2 gets me to 1/2, so I'll take 2 54 divided by 2, and that's 1 27 hundredths. 1/2 inch is equal to 1 27 centimeters. So when I say Allison's plant grows 1/2 inch per day, that also means it grows 1 27 centimeters per day. And now I'm looking at the centimeters per day. There's Allison's unit rate, 1 27 centimeters per day. Yuki's 1 375,000 centimeters per day. I compare their tenths place. I see Yuki's has a larger unit rate, and so I can say that Yuki's plant should be taller at the end of the year. Because it grows at a faster rate. It grows at a faster rate. In example 1, Sergio is training for a triathlon. His target speed is 25 miles per hour. Did he achieve his target speed for the first 7 miles of his ride? And so looking at the picture there, we see Sergio on his bike, and we're told that he travels a distance of 7 miles in 15 minutes. Okay, and his target speed is 25 miles per hour. So I'm going to set this up as miles to hours. And based off of the picture, again, I can see that he can go 7 miles in 15 minutes. Well, 15 minutes in hours, 15 minutes is 1/4 of an hour. 15 minutes is 1/4 of an hour. So we go 7 miles every quarter hour. I want to know how far is he going to go in 1 hour. This is going to help me figure out if he's going to reach his target speed of 25 miles per hour. So I'm going to go from my quarter hour to 1 hour by dividing by 1/4. And then I'll do the same thing to my number of miles, 7 divided by 1/4. And if I set this up, 7 divided by 1/4, I'll put 7 over 1. But I'm not really going to divide by 1/4. I'm really going to multiply by the reciprocal, which is 4 over 1. 7 over 1 times 4 over 1 equals 28. And so I can see from this that Sergio's biking at a rate of 28 miles per hour. His target speed was 25 miles per hour. So I can say, yes, Sergio reached his goal. His speed is 28 miles per hour. Okay? Now, we didn't have to set this up as miles to hours. We could have used the units given in the picture, miles and minutes. And again, I know that he goes 7 miles in 15 minutes. And I want to know how far he can go in an hour, which I know is 60 minutes. Well, to go from 15 to 60, again, all I have to do is multiply by 4. And I know 7 times 4 is 28. So he goes 28 miles in 60 minutes or an hour, which matches the work that we did over here. In the next problem, we're told that Sergio increases his target speed to 30 miles per hour. How many more miles does Sergio need to ride in 1/4 of an hour to achieve this target speed? So we saw from the last example that he's going 28 miles per hour. Now he's increasing it to 30 miles per hour. How many more miles does Sergio need to ride in each quarter hour? Okay, well, I'm going to set this up as miles to hours. And again, I know that he can go, or he wants to go 30 miles in 1 hour. Well, in order to go 30 miles in 1 hour, I'm going to figure out how many miles he has to go in every quarter hour. Okay, so I'm going to go from 1 to 1/4 by multiplying by 1/4. And I'll do the same thing to the 30. 30 times 1/4. Well, 30 over 1 times 1/4. 4 and 30 have a common factor of 2. 2 goes into 4 twice, into 30 15 times. So this becomes 15 halves, which I know is 7 1/2. So in every quarter hour, Sergio's going to have to go 7.5 miles. Now, how does this help us answer the question? Well, if you remember from the previous example, we saw in this picture that he goes 7 miles in 15 minutes, which is a quarter hour. Right now, he's going 7 miles in 15 minutes. And we just figured out he's going to have to go 7.5 miles every 15 minutes to reach this new speed. So how many more miles does he need to ride? Well, I'm going to have to take 7.5 miles and subtract the 7 miles that he's currently going. And this is going to give me 1/2. Okay, so Sergio needs to bike an extra ½ mile every quarter hour to reach his target speed. Okay, Sergio needs to bike an extra ½ mile every quarter hour to reach his target speed. In the next example, we're told that Bryn mows the lawn every other weekend. She can mow 12,000 square feet in 2/3 of an hour. The lawn is 36,000 square feet. How long does it take her to mow the entire lawn? And so for Bryn, we want to figure out how many square feet can she mow every hour. Square feet per hour. Okay? Well, I know that she can mow 12,000 square feet in 2/3 of an hour. And I want to know how long is it going to take her to mow the entire lawn? Well, I know the entire lawn is 36,000 square feet. So I'm going to set this equal to, in the numerator, it's going to be 36,000. And I want to know how many hours is that going to take. Well, this is actually nice because I can easily go from 12,000 to 36,000 if I multiply by 3. And so I'm going to do the same thing to my number of hours. 2/3 times 3. 2/3 times 3 over 1 is nice. The 3's simplify to 1's. And that gives me an answer of 2. Okay, so I can say it will take Bryn 2 hours to mow the entire lawn. It will take Bryn 2 hours to mow the entire lawn. In the last problem, we're told that every other weekend Bryn's brother Daniel mows the lawn. he can mow 15,000 square feet in 3/4 of an hour. I want to know who mows the lawn in less time. Okay, and so I'm going to have to use information from the previous part. I know that Bryn mows 12,000 square feet in 2/3 of an hour, and Daniel mows 15,000 square feet in 3/4 of an hour. And so I want to know who mows the lawn in less time, so I'm going to find their unit rate in square feet per hour. So I'm going to start with Bryn. And again, I'm setting this up as square feet per hour. And I know that Bryn can mow 12,000 square feet in 2/3 of an hour. I want to know her unit rate in square feet per hour. So in 1 hour, how many square feet can she mow? So to go from 2/3 to an hour, I'm going to divide by 2/3, which means I'm going to do 12,000 divided by 2/3. And setting this up, 12,000 over 1 divided by 2/3. I'm actually going to do 12,000 over 1 times 3/2 multiplied by the reciprocal. 12,000 and 2 have a common factor of 2. 2 into 2 once. 2 into 12,000 6,000 times. And so this is going to end up equaling 18,000. Okay, so for Bryn, her unit rate, she can mow 18,000 square feet per hour. Okay, and now I'm going to do something similar for Daniel. And again, I'm going to set it up as square feet per hour. And we were told that Daniel can mow 15,000 square feet in 3/4 of an hour. And again, I want to know how many square feet can he mow in 1 hour. So to go from 3/4 to 1, I'll divide by 3/4. And I'll do the same thing to 15,000, divide that by 3/4. 15,000, whoops, that was 150,000. 15,000, get rid of that 0, over 1, divided by 3/4. I'm going to really multiply by the reciprocal. 15,000 over 1 times 4/3. 15,000 and 3 have a common factor of 3. 3 into 3 once, and into 15,000 5,000 times. 5,000 times 4 is 20,000. 20,000. And so for Daniel, his speed, or not really his speed, but how much he can mow, Daniel can mow 20,000 square feet per hour. Okay, and so the question says, who mows the lawn in less time? Well, compare their rates. Bryn does 18,000 square feet per hour. Daniel does 20,000 square feet per hour. So I can say Daniel mows at a faster rate. Daniel mows at a faster rate. So he'll finish the lawn first.